Can you hear me now? Sorry, wrong company. All right, hi. You get to hear me talk a little bit again. I'm going to, yeah, you got it. All right, so I'm going to talk a little bit about applying ONOS in carrier networks, and it's going to be a bit about building up the kinds of use cases that make sense for a carrier. So I'm not going to go into a lot of detail on any given one, but sort of describe how we think we're going to make good use of ONOS and SDN. So to get there, I'm going to have to go through a little bit of history and build up a little bit of the background so you understand, well, so some of people like me could understand it. We have in AT&T some business imperatives. You heard Al mention them briefly, and this chart sort of lays out at a high level, we need to open our network. We need to find ways for other people to create innovative services and capabilities on infrastructure that we provide and maintain. We have to find ways to simplify and scale. And then, as Nick was pointing out toward the end of his talk, that a lot of the things here is value add, that you want to improve the value that's provided by networking. We got to get beyond sockets. And I won't belabor the individual points there, but say that we've developed an architecture and technology direction that we believe helps us get exactly there. And the way we do it is by decoupling hardware from software through NFV, by separating control from forwarding through SDN, and by combining these two. That it's not just one or the other, but it really is their combination and the cloud kind of operations model that we talked about earlier that enables this sort of real-time capability from networking, where we can distribute and integrate capabilities in the wide area network. So we just talked about this for a moment. SDN helps separate control and forwarding. It allows us to centralize and sort of repeat software patterns, right? So if you look at the myriad of boxes that we have in the network today, a lot of times we operationalize and learn and train and provide spares and maintenance on the same kind of function over and over and over and over, each time with a different logo on top of the box. But with SDN, you've got software reuse, right? To the extent that you can pull control plane into at least somewhat more centralized, if not completely centralized model, you get software reuse. NFV, the same story, and in fact I'll have a chart in just a moment that sort of pounds on this. But you get to recast network functions, pull them out of dedicated hardware with all of its myriad types of spares and training and support and whatnot, and introduce multi-tenancy and automation on common infrastructure. Individually, they sound great. They're very powerful concepts. But when you put them together, when you use SDN, for example, to provide composition of NFV functions, the quote service chaining you like to hear or read about in the press, to facilitate the ONM and other types of control that might be distributed into network virtual functions. That adds value. And NFV provides a sort of a common infrastructure upon which you can scaffold SDN, the operating system, and so forth. And it provides then common units of resource that get used for network functions. So, oh, that one came out great, didn't it? So this is basically the same picture that you've seen from Nick now for how many years has it been? And indeed, so the basic principle of SDN, sort of decoupling the apps and the common software operating system from the forwarding hardware. But the typical carrier problem space is a little bit expanded from the sort of clean slate view. So from an AT&T perspective, not only do you have the simple packet forwarding hardware that somehow managed to change colors on me, but you also have you have complex forwarding software. You have middle boxes like firewalls and gateways, and you have to cast a somewhat wider net than simply directive SDN. And so from an AT&T perspective, we look at ONOS providing a sort of the kind of function and clean slate in directives, but we also see that it has to fit into a larger ecosystem where SDN is sometimes used, let's say, to configure or control elements that are not yet white boxes, that are not completely down to the merchant silicon, and indeed has to sit side by side with legacy management systems and boxes that do nothing in the space of SDN. And so similarly, I'm going to bring up the concept of NFV, and with apologies to my favorite vendor here, if I look at one of those typical boxes that we deploy in the network, and I think about how can I refactor this hardware, how could I change the game here, this is sort of the mental image that comes to mind. So there is, in most of these type of vertically integrated devices, there's a fabric, right? And I can take that fabric, sometimes it's the backplane, sometimes it's a couple of cards, and I can plop that into the kind of fabric data centers typically deploy, you know, top of rack switches and end of row switches. And then I can take the other parts of what was a router, like let's say the I/O, which sometimes comes in fast models and sometimes comes in slow models, and I can attach these I/O things to that fabric and think of them almost like line cards that got attached to the fabric of one of these devices. And then finally, there's control. There's usually a control processor, which provides both the control plane and typically management plane. And then sometimes there are also apps, right? So there might be a gateway kind of device, and it terminates tunnels, or it provides deep packet inspection or firewall functions. And a lot of those things I can put into x86 or other types of general compute and run them as virtual network functions. And the thing is, I don't just want to do it on one box, right? The whole idea here is that when I start refactoring this, I don't just pick on my one favorite vendor. I go through all my favorite vendors, and this fabric winds up showing up in every one of these things, even the class 5 switch, right? And then I can put that on the same NFV infrastructure fabric. I can have the I/Os, Ethernet I/Os, look amazingly alike on all of these different platforms, right? I can make that refactored again. I reuse the hardware in this architecture. So where I have had in the past a dozen different boxes and a dozen different software loads and so forth, I now have a common infrastructure for a great majority of this. Like Nick was talking about, we have common non-differentiating software, right? The PHY that bringing up an Ethernet PHY or doing some basic packet shuffling is not really differentiating. And it's really, these things wind up becoming now the proprietary apps. Why did I have this box versus that box versus the third box to begin with? It was probably some feature, some proprietary app on top that made it worthwhile deploying that in the first place. And I'd like that to be just that piece of software and refactor and reuse all the rest of the software. So let's get back down to the point of the talk, right? So how do we introduce SDN and carrier networks? Or how do we get from where we are today to the sort of vision of where ONOS can help us? And there's sort of three basic sort of themes that I think make sense. So you can add SDN to elements that don't have a control plane. So believe it or not, there's still things in the network, and we'll get there in a minute. I won't go ahead before it's time. We can look for a place where we introduce a new network layer. So that, like so many times before, gosh, people remember Sonnet? Yeah, ATM, frame relay, right? These were network layers, and typically we would build a new network on top of the old one. How many people remember router on a stick, right? So this still happens, and maybe we'll find some new opportunities there. And then finally, we can create partial overlays with sort of putting SDN at the edges and leaving the middle of the network well enough alone. So walking through that, one of the first, and I think you'll see today, use cases that we brought forward to ON.Lab is, let's think about optical networks. So AT&T has a lot of route fiber miles, right? And if you look at optical networks, there's been some work in standards. I think they called it GMPLS, and many people would say, oh yeah, that could work and give you a control plane for optical, but by and large, it didn't go so well, right? But on the other hand, we could think about creating a directive SDN model for optical network elements. And it's really kind of good in some ways because unlike packet networks, optical networks don't have so many middle boxes, right? You got a wavelength, it's going to go here, it's going to go there, it might get regenerated, but it's fundamentally simpler and more tractable toward a directive kind of SDN. And so ON.Lab has been working on applying sort of the same kind of, what's a flow? Well, a flow might be a 5-tuple, but a flow could also be a wavelength, right? A route for a wavelength. And this is also, we looked at this, and there's evidence that if we had an optical network that was a lot more dynamic, that could be calendared or could be dynamically changed in case of failures or faults or other types of conditions, that we could make gains in terms of efficiency, we could make gains in terms of those pay-for services that Nick mentioned, and that this would ultimately be a good thing. So there's no king of the hill control plane on the optical network today that needs to be knocked over for SDN in order to get a foothold. And we think that this makes a lot of sense. And so I think you're going to see when the demos come up how this is a great model for ONOS. And indeed, I didn't mention it, but there's also benefit that could be had from sort of being cognizant not only of the optical layer, but also of the packet layer on top. So if you actually had control applications that not only knew the optical network, but also knew sort of the wants and needs of a packet network that overlaid it, then ONOS might be a really interesting thing for you to play around with. The second sort of pattern for a use case was to add SDN to new network layers. Okay, so where do we have a new network layer here? Well, I would claim that if we go back to that model about we've got this fabric that is used in NFV to stitch together all the constituent parts, that fabric is, gosh, first of all, it looks a lot like what they've put into data centers, the kind of top-of-rack switches and end-of-row switches. And by the way, those are the ones that pretty much support SDN better than anything else does today. So if we're going to start pulling together distributed network functions where you've got line cards, you've got applications, and you've got perhaps other aspects that are not strictly networking, one of the ways that you can compose this is through this fabric, which could very easily be SDN controlled. And then lastly, you can create an overlay network. So let's say, for example, that you do have a very complex control plane driven network, and it's kind of risky to be sort of messing around with that at this point in time. Well, maybe you leave that MPLS core alone to begin with. You find ways to direct, influence, or pull information out of that core network so that it becomes part of your new API and view in an SDN controller. And then you start putting simple forwarding hardware at the edges. This is where, frankly, this is where we spend a lot of our money, is on the edge of the network. There's very little spend in the core. It's complex, it's risky to change, but we can experiment and develop new services at the edge that are driven by SDN. And so we think there's a lot of opportunities here in a lot of areas where we can keep the core alone, leave it alone for a period of time, let it take its course, and then start developing new applications around the edges with SDN. And it really kind of repeats historical success. If you guys that remember Sonnet and Frame Relay and ATM, it was very much the same kind of idea. Okay, so key takeaways. I think you've probably heard our messages today that we really are all in on this next generation approach. It is for us very much do or die. That we believe that SDN and NFV, even though they might not be called that in 20 years' time, they're really key technologies and they're symbiotic. They really kind of feed off one another. And that we think we can apply SDN, kind that ONOS does, in several kind of basic ways. Apply it to places where you don't have a control plane, apply it to new kinds of new networks, new layers, and to apply it to overlays, which is in some ways also a new layer. And finally, for those of you, remember that Al mentioned that we had this white paper that we've developed and put out for reference. The link at the bottom of this chart goes to said white paper. Okay, so thank you very much. Any questions?
Any question for Tom? Right, you need to